Hello, geometry students. In this lesson, proportional triangles, triangles that are similar and have proportional sides. So look up number one. Given that these triangles are similar, I want to figure out the length of x. So I'm going to set up a proportion on every one of these, where on this one I'm going to say, looks like the short side and then the long side. So I am going to set up my proportion as short is to long. So short, I say stay on your own triangle. Although there are other methods, I think this is probably the safest. So I'm going to stay on my own triangle, and I'm going to say the short side is 3.5 centimeters to the long side, which is 8.4. Now I'm going to go set up a proportion on the other side. As long as you're careful and don't get it twisted and say short is to long, you're going to be safe. So short side is 5. The long side is I don't know. I've set up my proportion. You know how to solve a proportion. Basically, you cross multiply. The shortcut is to always divide by the number that is diagonally opposite. So the x is going to be divided by 3.5. And before you put a box around it, 8.4 times 5. I get 12. 12 centimeters for that long side. And like I said, before you put a box around it, does this seem reasonable? It doesn't seem unreasonable. If this is 5, that certainly could be 12. So that is the length there. Using similar triangles, I set up proportional sides. We've seen something similar already, but this case, I'm telling you they're similar. Same thing here. Solve for x. I'm just going to set up a short is to long. And as long as you keep it straight, you should be good. So I like to stay on my own triangle. So I'm going to compare the short side on one triangle with the long side on one triangle. So looking at my first ratio, on the small triangle, the short side is 5, the long side is 8. On the other triangle, the short side is 7.5, and the long side is x. So setting up your proportion is the most important thing. Of course, solving it's important too. Remember, you're going to divide by the number that's diagonally opposite. It so happens that the variable was in the same place on both of these. It doesn't have to be. The variable can be anywhere. Proportions are actually pretty flexible as long as you just don't get them twisted. What I mean by that, is that 12? Yep. What I mean by that is you don't have to stay on your own triangle. I could have done this as 8 is to x, as 5 is to 7.5, and I would have ended up with the same thing. You divide by the number that's diagonally opposite. So that was not staying on my same triangle. That's just another example of a way to do it. It ends up being the same thing. How about these nested triangles? If you have a parallel where you have a side that is, a segment that is parallel to one of the bases or one of the legs of a triangle, you can set up quite a few proportions actually. Notably, the distance, if you set up with the legs themselves, so AC is to CE, the same way that AB is to DB. Those are supposed to be different colors, but you can't really tell. So they're not congruent, but they're actually proportional. So if you look at this one, I can say that 6 is to 8 the same way x is to 5, because they are proportional. So I don't really have words for these. One looks like a long side and one's a short side, but they're not always going to be that way. So I'm just going to say, I don't know, top is to bottom. I just going to use this as a reference for what I'm going to set this up as. So I'm going to say 6 is to x as 8 is to 5. So you know how to solve proportions. You cross multiply, or essentially you divide by the number that's diagonally opposite. 30 divided by 8, it's going to be a decimal. Oh no. 3.75. And again, does this look like it could be 3.75? It does. Always check to make sure you've answered the question. It was just asking for x, but I could just as easily have asked for the length of this side, which that will also work as a proportion. How about this one? This is just an algebra problem disguised. So there's the top is to top as bottom is to bottom. I think the way I said that would not be the way I would write it out. The way I would write it is to say top. I'll do that in green. Is to bottom. And of course what I mean by top and bottom is the top of the triangle, which is x plus 3. X is the bottom. The top is 6 and the bottom is 4. Got to be careful about these because you could end up with a quadratic. Oh no. Which one is the variable? This one is one that I have to do top times bottom equals top times bottom. Incidentally, what I mean by this is the top of the proportion times the bottom. So I'm going to say the top of this proportion is x plus 3. The bottom that gets multiplied is 4. The top of this other one is 6. The bottom that it gets multiplied by is 6. I mean x. So this just turns into a mid-level algebra problem. 4x plus 12, don't forget the second term, equals 6x. Got to get my x's together. Looks like x equals 6. That's the answer, what it was looking for, but I'm going to plug this in. That makes this number, this one 9, and this one 6. And so you could actually do a quick check. Is 9 is to 6 the same way 6 is to 4? They're both 3 halves, so yes, it checks. So there's an algebra problem.